Trig Substitution Part 3, Substituting with Secant. The integral of dx over x times the square root of x squared minus a squared is 1 over a arcsecant of x over a. Let's take a look at integrals that are similar to arcsecant. First, can you think of a simpler way to do this integral other than a trig substitution? If not, how do I know that it's an arcsecant or a secant substitution? Well, it's mainly because of this top part has a similar form to the bottom part of arcsecant. And that's a clue that I'm going to do secant theta equals x over something to build my triangle. Now, looking a step ahead, does x over 1 work? It doesn't look like it, because I really need x over a. So it makes more sense to start with secant theta equals x over 3. And we'll see if it gives us what we need. So secant is hypotenuse over adjacent. If that bothers you, you can think of cosine equals the reciprocal, and you can fill in your triangle if you like to do it that way. So how about this third side? If I do Pythagorean theorem to get the third side, we do get what we want. That is, the third side is the square root of x squared minus 9. So let's go through the process of substituting every piece with an x for something with a theta. I know that x is 3 secant theta, which means that dx is 3 secant theta tangent theta d theta. And we already have two of our pieces. We have the dx and we have that x on the bottom. We need to handle the rest of the numerator. And looking at our triangle, we see that the tangent of theta is square root of x squared minus 9 over 3. Which means the part that we want, the square root of x squared minus 9 is 3 tangent theta. So we can go ahead and substitute in. We will end up with 3 tangent theta times the dx, which is 3 secant theta tangent theta d theta, all over x, which is 3 secant theta and we can start to simplify. Those 3's will cancel, those secants will cancel, and we get 3 times the integral of tangent squared theta d theta. Thinking back to our trig integrals, we can rewrite tangent squared as secant squared minus 1. Because that will give us 2 very straightforward integrals. In fact, the antiderivative of secant squared is tangent theta. the integral 1 with respect to theta is theta. And now we can back substitute. We already know what tangent of theta is. It is the square root of x squared minus 9 all over 3 minus theta. Well, we chose secant theta to be x over 3, which means theta is the arcsecant of that. I'll go back up so we can see it again. If secant theta is x over 3, then theta is the arcsecant or inverse secant of x over 3, which is what we will substitute for this theta. Let's take a look at one more example. Let's do the integral of 2x cubed times x squared minus 9 square rooted which looks a lot like an arcsecant, sort of. I mean, it's in the top, but you might think this is a secant theta substitution. And it could work. But we really want to do the simplest way to do each integral. So you can, on your own, try to see if secant theta might work. I'm going to try u substitution instead. We're going to let u equal x squared plus minus 9, and du is 2x dx. And you might think that doesn't really seem to help us, but what if I rewrite the problem like this? I'll just kind of reorganize things. It's certainly a true statement. X squared times the square root times the 2x. And then if I substitute in my u's, I get x squared times u to the 1/2 times du. And if you're bothered by the x squared, we don't need to be, because I know that x squared is u plus 9. And then I can rewrite this as u plus 9 times u to the 1/2 du. Or u to the 3/2 plus 9u to the 1/2 du. We'll finish this off. I get 2/5 u to the 5/2 plus 9 times 2/3 u to the 3/2. And then we can back substitute for our u, giving us 2/5 times x squared minus 9 to the 5/2 plus 6 times x squared minus 9 to the 3/2 plus c. So that's a little bit messy, but I would rather do that than have to do a trig substitution.